Problem 57, it's just the same as the last problem that we did. What was that? Number 39. All of these are solving systems of equations using matrices. This happens to be a little bit more work because it's a system of 3 equations with 3 unknowns. So the first thing we want to do is rewrite the system of linear equations as a matrix. So we're just going to peel off the coefficients. Peeling off the coefficients, all of the terms are in order, so that makes it nice. The vertical line represents the equal sign, and those brackets on the outside represents that we have a matrix. And then remembering the steps, we have our diagonal. So let's indicate our diagonal. So these guys right here are along the diagonal, and we want to get zeros in the first column under the diagonal, and then after that we would get a 0 in the second column underneath the diagonal. So that's our first order of business. Again, to get zeros below the diagonal from left to right. It's the first thing we're going to do. And so how do we do that? Well, it's nice to have a 1 right there in the first position, because then we can use that 1 to get zeros in the other 2 rows. So we're going to take -3. So our new row 2 is going to equal -3 times row 1, and we're going to add to that row 2. -3 times row 1 would look like this: -3, -3, +3, and then -3 times 6 is -18. Row 2, the current row 2, is 3, -2, 1, and -5. When you add those two together, you get 0, -5, 4, and -23. All right, so that becomes our new matrix. So our new matrix, row 1 stays the same. Row 2 now this is the new row 2. So row 2 now becomes 0, -5, 4, -23. And at the same time, we're going to go ahead and change our row. Well, let's do this. Let's so it doesn't get too confusing with how much I'm writing. Let's rewrite row 3. So okay, so we have row 3 there, and now we're going to change row 3. So our new row 3 is going to equal, let me scoot it up here a little bit. The new row 3 is going to equal -1, or let's just do this. Let's just do row 1 minus row 2, or sorry, minus row 3. Let's make it simple. So to get from this matrix to the next one, we keep row 1 the same. Keep row 2 the same because we got our 0 right there. And then our row 3 is going to be changed. We're going to take row 1, and let's see, would that be better than that? Let's go ahead and take, I'm debating on whether to take row 3 and subtract. Let's do that because we have a bigger number down here. So let's do row 3 minus row 1. And so we take 1 minus 1 is 0. 3 minus 1 is 2. -2 minus -1. -2 minus -1 is -2 plus 1, so that's -1. And then we have 14 minus 6 is 8. That gives us 2 of the 3 entries in the third row now are positive. So our new row 3 is row 3 minus row 1. So now we got 2 zeros in the first column, and all we have to do now is to get a 0 and underneath the diagonal. So this guy right here, we need to change that to a 0. And the only way we're going to be able to do that, by the way, we want to only use row 2 to do that, okay? Because if you use row 1 to do that, then you're going to get a non-zero entry in the first position here. So it's going to change that 0. So we have to use row 2 to do this. So our new row 3 is going to equal, think about this, we're going to take 2 times row 2, and we're going to add that to 5 times row 3. All right, see why this works. 2 times row 2 is going to be 0, -10. 2 times 4 is 8. 2 times -23 is -46. 5 times row 3, now 5 times row 3 would be 5 times 0 is 0. 5 times 2 is 10. 5 times -1 is -5, and then 5 times 8 is 40, and that then becomes, once we add these two together, we get 0, 0, 3, and -6. So that's pretty nice because that's our new row 3. And now we just rewrite the matrix, and we are done doing our row operations. We have rewrite this first row. We have 1, 1, negative 1, and 6. Rewrite the second row, 0, negative 5, 4, and negative 23. Rewrite the third row with the new third row, 0, 0, 3, and negative 6. So that becomes our kind of like a row echelon form, but row echelon form, technically you have ones in those along the diagonal, but you don't need to have ones there. It sometimes is helpful, but if you are introducing fractions, then I find that to not be so helpful. But now we want to backfill. So now we're here at this step. Once we've got zeros below the diagonal, we want to backfill, and we would rewrite the system. 1x plus 1y minus 1z is equal to 6. That's our first row. We have negative 5y plus 4z is equal to negative 23. And then we have 3z is equal to negative 6. So it allows us to solve for z. So if we divide both sides by 3, we get z is equal to negative 2. So there's one value. And let me see if I can squeeze this in here. If I then back up to the next equation, we're going to use negative 5y plus 4 times z. Again, z is negative 2, is equal to negative 23. I'll try to do some of this in my head so I can squeeze it in here. Negative 5y minus 8. So if we add 8 to both sides, we get negative 5y. Adding 8 to negative 23 gives us negative 15. Dividing both sides by negative 5 gives us y is equal to 3. Okay, and now again we're backfilling. We're going to go back up to the first equation, and we have the first equation. There's only one unknown variable, that's x, because x plus y, again y is 3, minus z minus negative 2 is equal to 6. So we have x plus 5 equals 6, therefore x is equal to 1. And we found our x, our y, and our z. And if you want to put it as an ordered triple, x goes first, then y, then z. So that becomes our solution. We can leave it alone. You don't have to write it as an ordered triple. But nevertheless, that is how you solve a system of 3 equations with 3 unknown variables.